All right, so here's the problem. Bob's got 10 meters of fencing to create a triangular chicken run against an existing wall. So you can see the wall there in grey, and the chicken run is of a triangular shape. Now, because he's got 10 meters of fencing only, and there's only two sides, right? So you could make both sides 5, you could make one side 10 and the other 9. And that's why what we've got is this thing over here where I've got y is equal to 10 minus x. So just to explore that just a little bit further, remember the area is equal to, in this case, a half base times height, isn't it? We know that area of a triangle is half base times height, but the base this time is y, and the height is going to be x. So I've just got half yx or half xy, and that'll work out. And you can see there that we can work those things out. So we can create different shaped chicken runs. So, you know, another option, this is one where they look sort of similar, but I could create, you know, another one where this is really, actually, I'm not sure how it's going to work, is it? But we can turn these things around. Actually, that's not done very well. Let's muck around. So we can do this sort of thing where we've got, actually, that's no good either. We'll get there. We can do this sort of thing, okay? So where we've got a wall still at right angles, and you can create different shapes and different lengths up against that wall, okay, and still having right angles. So hopefully you can see that we've got different options that we can create in those directions. I'll just move that out of the way because it's a little distracting. So you can change, okay? You can change the length of x and you can change the length of y as long as both of them add up to 10, okay? So I want you to understand why we have this thing here, and I've got y is equal to 10 minus x, okay? And the reason that is that if x is equal to 9, then y must be equal to 1, isn't it? Because they need to add up to 10. And we go 10 minus 1 is 9. If x is equal to 6, then y must be equal to 4, and you can see 10 minus 6 is 4. Okay, so there's no big deal there. So to solve this problem, we need to set up a table. So we'll go ahead and do that off to the side here a little bit so that we're still looking at it. See if I can squeeze a table in over here. So I've got x, y, and then I've got the area. Okay, and we can start to put some values in for x. So let's start with, I'm not going to do 0, right? Because 0 is going to give me 0 area. Either x or y is 0, the whole area is 0. And we're trying to find out the biggest area. So 0 is not going to be it. So I'll start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we'll just increase the length of those, looking a bit ugly. So if x is 10, then y must be 9, isn't it? Because they both have to add up to 10. Okay, that must be 8, 7, 6. What's next? 5, 4, 3, 2, 1. And we said we weren't going to do the 0 thing, so 10 doesn't work either. And now we can work out what these areas are. And the area is half of x times y. So 1 times 9 is 9, and half of that is 4.5. So if this is meters, and it is meters because it has 10 meters of fencing, then the answer is going to be 4.5 meters squared if I've got that arrangement. So let's try the next one. What about 2 and 8? Well, half the base, if you like, is, if the base is that, it's 4. 2 times 4 is 8. So that's a big improvement already, isn't it? So we've gone from 4.5 to 8. And then 3 times 7 is 21, and half of that is 10.5. And 4 times 6 is 24, and half of that is 12. 5 times 5 is 25, and half of that is 12.5. So it seems to be increasing as we continue to go up. So the question is it going to continue to increase? Well, we'll have a look. Okay, you think probably not, because we're starting to mirror things, aren't we? So look, if I've got 4 and 6 over here, then suddenly I've got 6 and 4 over here. And it should give me the same number, shouldn't it? Because we go 6 times 4 is 24. Half of that is 12. So it looks as if we've peaked at 12.5. But let's keep going, okay, just to be sure. So half of 21, 10.5, 8, and here we got 4.5 again. And if we keep going, we do get to 0 and down in that way. So we found the maximum area, and the maximum area is 12.5 square meters when X and Y are the same. Kind of makes sense because the more regular shapes tend to maximize the area. Okay, and that's just a rule we find. So if we've got sort of skinny triangles, they tend to be smaller areas, but if I've got triangles with similar length sides, they tend to be larger, which is what we've got over here. So in terms of a right angle triangle, that's the biggest one we can get. So the maximum area is equal to 12.5 meters squared when X is equal to 5 and Y is equal to 5. And this is what we call sort of maximizing solutions or maximizing things that we've done in that way. And we can do it with a table. Come back next year and we'll find another way of doing it. We can do it with calculus as well, which is very nice. But at the moment we're using a table, and a table is fine for this kind of thing. You can see quite naturally how we can maximize something like that. So let's look at another problem, and this problem comes from the textbook that we're using. So an airline has a contract to fly soldiers from New Zealand to a battle zone. To save money, the flight should have as few empty seats as possible. So that's key there. We should just note that. So as few empty seats as possible. So just get your head around that. And then it tells us that there are 2 types of aircraft that we can use, an Airbus and a Boeing. So it's very convenient. One starts with A and the other is B. That's very nice when we're doing maths, that we can just reduce that to A and B. And it's got a seating capacity. So we're just going to do A to start with, and then later on you can have a go at B. But it's good. How should the aircraft be allocated if there are 1,000 soldiers all together? And what that means is let's work out. Maybe we're going to have 4 Airbuses and 5 Boeings, and that'll do. That'll certainly get us 1,000 soldiers. But I suspect that solution is going to have way too many empty seats. So we're trying to maximize, or actually we're trying to minimize something in this, can't we? We're trying to minimize the number of empty seats. Well, we need to do a table for this as well. So just keep those things in mind. So we've got 305 and 375, and I'll set up a table over here where we've got the 2 different types of aircraft. So I'm going to do aircraft A over here, aircraft B over there. Aircraft A, which is the Airbus, we'll just note that down. It's got 305, and the other one has 375, and that's sort of useful. And then we'll just create some columns. So we'll go down in this way. That's looking very nice. And so I can have 0 Airbuses, 1, 2, 3, 4, probably enough. Then I'll do the same for the Boeing. Okay, so we'll go 0, 1, 2, 3, and 4 if we need it, but we might not. Okay. And then we have a look, and so we start filling in that table. So let's start with the blindingly obvious, is that if we've got no planes of either type, then we've got no soldiers that can go on the flight. So that makes sense. So if I've got 1 Airbus, then I can take 305 soldiers. Is that okay? See that? So I'm just looking at Airbuses there. 1 Airbus, I can take 305 soldiers only. If I've got 2 Airbuses, I can take 610. So still not enough, eh? I need to keep going until at least I've got enough. And then if we add another 305, that would come to 315. Still not enough. But if I add another 305, it comes to 1,220. So I can stop now because I've got 1,000 soldiers. So I can fly 1,000 soldiers with 4 Airbuses. All right, what about if we start introducing the Boeings into the equation? So if I have got 0 Airbuses and 1 Boeing, then I can fly 375. Then what about if I got 1 of each? So 375 plus that one gives me 680. Okay, so that's 1 of either plane. 1 Airbus, 1 Boeing means I can put 680 people on there. Let's add another Airbus. So if we add 305, we get 985, I think. So still not enough. Add another Airbus, and I've got 1290. Okay, so now I've got enough. So I've got enough soldiers if I have 1 Boeing and 3 Airbuses. Okay, and that gives me this solution over here. But can you see which of those two? So I've got 2 possible solutions now, haven't I? 1220 and 1290. Now, the one that minimizes the number of empty seats is going to be this option here. Okay, the 1220 option, because we're going to end up with 20 empty. No, we're not. We're going to end up with 220 empty seats, aren't we? It's the number over 1,000. Okay, so this gives me 220 empty seats, whereas this one gives me 290 empty seats. Okay, and all of the other solutions, they don't work. So those are some options. So let's keep going. What about if I have 2 Boeings and no Airbuses? That gives me 7. Oops, change the pen there. What's going on? Rub that out. And now I can't do addition anymore. 750. Okay, add. So that's not enough. So if I then add an Airbus to that, so if I get 2 Boeings and 1 Airbus, I get 1,055. If I add another one, I get 1,360. So we can actually stop there. I don't need this last one at all, do I? Because in fact, let's rub that out, because it's just going way beyond. So I've gone, as soon as I get over the 1,000, I can go stop going across. And then the last option is 3 Boeings, and that gives me 1,125. So I'll shade in green the 4 possibilities. Everything that's not shaded is not an option because we don't have the 1,000 soldiers that we need. Okay? And really, I'm looking for the one that has the least seats. Okay, and in that case, it's this one, right, which is 1,055. That minimizes the number of empty seats we've got down to 55. So the solution we've got, 1 Airbus, okay, which is if we follow that column through, okay, 1 Airbus and 2 Boeings, okay, and so we can state 1 Airbus, 2, that's what Boeing, 2 Boeings, I forgot now. Oh, I've also got an E in there somewhere. We'll just stick the E there because we don't want to lose it. So 2 Boeings, which gives us 1,055 seats, and 55 are empty. And that is the least amount that we've got. And so let's look at that again. Notice that with the first example, okay, we were looking at basically one sort of thing. We're looking at a length only. And this example here, we're looking at 2 different types of aircraft. And notice the table was a little bit different. We need to create a grid for this type of solution. So we need a grid here, where in this example here, this is more of a simple solution, where really there's only one variable involved, and that's x, because y is really 10 minus x. So this is sort of what we call a 1 variable problem, simple table. But over here, we need a grid because we're dealing with 2 variables, 2 different types of aircraft, and we need to compare it in that way, and we set up a grid. Now, often with these grids, spreadsheets can be used to set up those grids. And we could have done that here too, and it would have made life really easy for us because you can automate all of that with equations in the cells. But this is a relatively simple problem, and we can do it sort of fairly quickly with what we've got. Wonderful. So I'm going to put a couple of problems on the board for you.